At this point, we've set up the required infrastructure services and staged our Python script. It is finally time to provision some new devices to test the entire solution. I've just booted up Site 2, one of the remote sites. All router serial numbers were already accounted for in our IP address map within the ZTP script, so this device should have a unique configuration when ZTP completes. This process can take several minutes. I'll be fast forwarding and trimming footage so as not to waste your time. We'll review the logs later. Let's first wait until the Site 2 shell starts responding. The vast majority of iOS XE devices have their HTTP servers enabled by default, but the CSR 1000V does not. The ZTP process requires this service for internal communication, or else the Python script will malfunction. We need to manually enable the HTTP server before the guest shell container finishes starting. This is a platform-specific hack that you will not need to do when dealing with your production devices, such as campus switches or branch routers. Let's configure IP HTTP server quickly to enable it. Now, we just wait for the process to complete, at which point this new site should be on the network. Okay, the process just finished. Right away, we see our dynamically updated hostname, which is good. Let's ensure Site 2 has formed an OSPF neighbor with the hub by issuing the command show IP OSPF neighbor. 10.0.0.1 is the hub's router ID, so this looks good to me. We should be learning 10.0.0.1/32 as a route via OSPF through Tunnel 100 as well. We can use show IP route for that specific prefix to confirm. Again, this looks good to me. Let's test connectivity using ping towards this IP sourced from our own loopback. Okay, everything is working and we've confirmed that Site 2 is officially on the network. Let's scroll up and review the logs. Gigabit Ethernet 1, which I'll call Gig1 for short, receives an IP address at boot time. I wasn't able to find a log entry for it, but more importantly, the router knows the TFTP server based on option 150 carried in the DHCP offer message. The router then downloads the Python script named ztp.py from this IP address. Remember, the option 67 was used to signal the name of the Python script. When the script is downloaded, it is renamed to downloaded_script.py to normalize the ZTP process. The router needs to execute this script, but needs to start a guest shell container first. This process takes a few minutes, and the intermediate logs aren't terribly interesting. Let's scroll down. Earlier, we manually enabled the HTTP server as a workaround to demonstrate ZTP on the CSR 1000V. Shortly thereafter, the guest shell container was successfully started. Let's keep scrolling. At this point, the Python script executes inside of guest shell. Notice how Python 2 is used, and again, I imagine this will change to Python 3 soon. The output lines that begin with asterisks were our custom print statements inside the script. The first thing our script did was capture the serial number, then print it out for confirmation. Next, the script begins configuring the device, dumping in that big list of commands we specified. Here are some of the commands as they're being issued, and we can check our logs to see them being applied correctly. To finish up, we run the verification commands in a for loop, beginning with show IP SSH to ensure SSH has been configured. Next, we check our IPs, and we can see the correct IPs have been configured. Also note that Gig1 has a DHCP issued IP of 203.0.113.11, which makes sense, because .0 through .10 were off limits. Finally, we see the DHCP lease and OSPF interface details. Most importantly, OSPF is enabled on our loopback and tunnel interfaces as expected. Most of the remaining logs relate to either enabling netconf yang, which we will use later, or terminating the ZTP process. We won't scrub those. Let's quickly provision Site 3 next. I won't detail the whole procedure again, but will instead trim the footage so we can review the logs and network state once complete. Let's ensure the OSPF neighbor came up. Okay, as expected, Site 3 connected to the hub without any issues. Let's scroll up to the point where the ZTP script began execution. Because Site 3 has a different serial number than Site 2, the IP address map returned a different two-tuple of addresses. This time, we have 10.0.0.3 as the loopback, for example. Let's jump over to the hub and ensure it sees both Site 2 and Site 3. We can use the show IP OSPF neighbor command again, except this time we should see both 10.0.0.2 and 10.0.0.3 to represent Site 2 and Site 3 respectively. Looks great to me. Let me finish up by sharing two important points. First, if you want to force ZTP to work again on the CSR1000V, just delete the startup config file. Use the command shown on the ZTP spokes, then reboot them, and you can easily test ZTP over and over. For my second point, let's go back to the dev box. I've stored an example bootlog in the course files named bootlog.txt. Let's peek at the first few lines. Like most log files, it is long and complex, but is worth reviewing as an example of what right looks like. I encourage you to reference this file when you test ZTP in your environment.